All right, today let's talk about tree-based models, right? You may have heard about RStudios, decision trees, random forest, which other one is there? Light gradient boost models. But how it works is it takes a look at all the predictive variables or predictive factors and then creates nodes, right? Decision node, the leaf node, decision nodes where it sees that it generalizes well. Then from there, try to create another subset of your data set and then try to create inferences from what it sees from that subset against your target variable. And that's how it works. It keeps creating these subsets until it finds a best fit. Then it returns that best fit as your model predicts new variables on unseen data. So that's essentially what it is. The four common types of tree-based models are decision trees, random forests, gradient boost models, and SG boost models. And then in this tutorial, we're going to look at those four types and how to implement those four types using a tidymodels package in our RStudio. We give you an idea of what the fundamentals are and how you can go ahead and fine tune and enrich this model. All right, so from here, we're just going to speed through it. As you can see, I've called out my required packages and installed them if they are not already installed. Then I use my library function to call those packages. Next, I'm setting a random seed so that the results are reproducible. And then I'm setting my work directory to where I've got the data set. Now I'm calling on the static portion of data sets. I think when you look at the data source itself, you're going to see a static data set that was taken at once and some other longitudinal version that was taken over a time series. So this is what the data set looks like. The and variable here just shows that all these values are right-handed, and so we'll be dropping that value. And then we're going to handle for missing values by replacing it with the average value in that variable. So that's what we're passing there. And we're turning our CDR into a factor variable and generating a new variable called dementia. That is where the CDR value is 0, then dementia is absence. Any value above 0 is 1, indicating that dementia is present. All right, so what we now is to now make a copy of our data set, which will be passing to our recipe, right? We'll be exempting a few variables here. Then we're going to initiate splitting. Now, the thing about why our or the model development at R is such a great thing is because of our tidy models package. And the way it works is you just create recipes and then you join that recipe with your model function in a workflow, and then that makes it possible for you to just use it as a template and duplicate things. So yeah, we'll be working with 4 different tree-based models, but we just need to initiate that recipe once. And that recipe is simply going to take all the steps that we want to carry out on our training data set before we start to initiate model development. And then we're also going to do a little bit of research with hyperparameter tuning. And here you can just see an example with this tree-based model. Right, so we're creating a recipe saying dementia is our target variable, and our data is training data sets. We want to input mean on all numeric predictors, right, and domify all our nominal predictors. So that's essentially going to do is just make sure everything is in a proper form, and then normalize our numeric values here. And we're going to call the main decision tree function here on a classification mode and indicate that we want to tune across complexity and the tree depth. right? Then you set an engine. Depending on what you already see on your EDA, that should inform your the number of folds, cross-validation folds you want to use. But you could also just go arbitrary. Like here, I'm just doing 5 folds. Then I start with my grid search on my cost complexity and a range for my tree depth, right? And I pass the folds as levels. And you see what I'm saying about the workflow thing. On the workflow, you just take your recipe and then join it with the model you've already defined earlier. Now, to get the results, you want to tune that workflow and then resample across your cross-validation folds. The grid is going to take your grid search function that you defined earlier. The best parameters are the parameters that have the most accurate metrics. So what you want to do after you've got all of this is now create a finalized model workflow. Then you take the tree workflow against the best parameters. You want to fetch the results from this final tree or this final workflow you've created, which is the last fit, the best fit. And then from there you can start to fetch your predictions and build the confusion matrix. So we had an issue here where the data we passed to our model training itself are taking extra steps outside what our original data frame looks like. So in this case, it's showing that the gender MF variable is a character, not a vector. That's because we had already added the step dummy to all our nominal predictors. We just create a factor, but in the dementia actual pre-processed data set that we're using to check for predictions is still carrying the gender variable as a character. So we want to make all our modifications happen in the pre-processing stage before we pass them to our recipe so that it just works. And now you can see that after we made those changes, it works. You want to fetch your predictions from the final results and then build a confusion matrix. So you can just get an estimate by looking at the graphical output of that confusion matrix and see how well your model generalizes on unknown data, right? So here we can see the predictions, the strength of predictions here, and we see that where dementia is actually present, there's very, very little cases of misclassification, indicating that a model performs well. So that's it for decision trees. We're sort of going to just replicate the same thing for a random forest and then see how it works. Okay, now we're working with the random forest. You can see we're just making a copy of things and then changing the names really, and then looking at the parameters we passed. So alright, so you can see the output of a random forest model. You can see how that is stored, and I've got a very fantastic result confusion matrix here. We can see some misclassification with where dementia is absent, but you can see how well it really generalizes for how well it really predicts for where dementia is present. So, and we can almost attribute some of that success to the tuning portion of it. Now we want to look at gradient boost models, right? Gradient boost model, because it's a little bit archaic, passing a bunch of parameters and see how it works. Alright, so you can see the relevance or how very important or the feature importance graph and their levels over here. You can see gender, even education and age doesn't really impact as much as the mental state and then the socioeconomic state of these individuals, which is very telling. So you can go ahead and just make your predictions over here as well as build a confusion matrix. So the results here, we can see for our prediction again reference, again the zero portion of it is kind of where dementia is absent, is kind of not so accurate, and you can see for where dementia is present, it performs quite well. Accuracy here is 68%, which is not bad, not good, but kind of fair. And the other values are like the p-value, sensitivity, specificity. So we're just going to move on to the XGBoost. XGBoost is going to take the same workflows, the same steps as we've done with our tidymodels templates. Here we're just going to change a few parameters there. Add a set mode instead of a mode within its function call, and then set the range of what we want to tune for, right? So we're going to just take the same steps. Tuning here is going to take a little bit of time. But hey, we've got the result out of the control matrix. Kind of looks like the same result we got from our decision trees, not as good as what we got from the random forest. Well, anyways, but you can see how those very 3 or 4 variants of tree-based models. I really hope this helps, and if it helps, please just drop a like or subscribe, or just do your thing and build something cool today.